equation of the ellipse that has that information? Well, once you know what side your vertex or your co-vertex is on, you will then know what side the a squared is going to be on. It's either going to be underneath the a or under the x or underneath the y. So knowing that, excuse me, my co-vertex is here and I have a focus here. Where do vertices go in terms of with their focus, or their foci, excuse me? They're on the same line. That's what I'm getting at. Foci and vertices will be on the same spot. So that means my vertice would be here, which means it has to be stretched vertically, which means it'll be x squared over b squared, y squared, a squared, just 1. So what we do then is just take the values. Co-vertex is center to vertex. Co-vertex is b. So b is 5 root 11, which means you have to square that. So 5 squared times 11 gives you b squared. Oh. Was it? 275. Focus is 7, because we're centered at the origin, so 7 will be the distance from 0 to positive and 0 to negative, doesn't matter. I square that. I should not be talking over you guys. Okay? I shouldn't be. I square it, and I get 49. That's a plus sign between, which means in order to find the missing value, we have to have a minus between. And there's a reason why I'm trying to re-emphasize that point here right now, is because today, hyperbolas are minus in the equation, plus with the a squared, b squared, c squareds. So this means that 49 is going to equal a squared minus 275. What's a squared then? You just add it over. A squared is 324. So now you have, you know what your b squared is, you know what your a squared is. Answer is x squared over 275. Y squared, 324. Write it out, okay? People do that a lot. Make sure, and I was bad on this case. I should have written it out. Make sure you write it out. Yes, ma'am. What do you got? Mm-hmm.
I just didn't get like how to move it over.
And I was talking with people about this a couple of times today. When you think about, we're all in agreement at this point that this has to be a hyperbola, correct? It has to be a hyperbola because there's only a singular squared term. It's an x squared hyperbola. Now, if it's an x squared hyperbola, there's two formulas. X squared equals 4py, or y equals ax squared plus bx plus c. Those are the two generic formulas we have for parabolas. In this case here, I'm going to have to do this one. The reason that I have to try to do that is because if I move things around in the x squared by itself, I'm still going to have this 1 minus that 4y. I can't figure out a p-value out of that because there's this 1 tacked onto it. It won't work. So that means I have to shift gears and try and do it via the old-fashioned way of the axis of symmetry and all that kind of fun stuff. Get y by itself. First thing I'm going to do is multiply everything by 81. Okay. 81 x squared plus 36y is 81. I was just checking to see if you're paying attention. Way to go.
Yeah.
Sorry about that. Now get y by itself. Easiest way to do that, I'm going to move the 36 to the right, 81 to the left. and then divide everything by the, it'd be negative 36. So I'm going to write this as a fraction. Negative 1/36 x squared plus 9/4 is y. I'm just bringing the y to the left-hand side. In my mind, we always see y equals something. Mx plus b, whatever the button our calculator says y equals. I'm going to go from there. Now it's in the generic form of a parabola, with, or I should say standard form of a parabola, ax squared bx plus c. And the easiest way to graph this one is to go via axis of symmetry. What's your value of b? 0. So my axis of symmetry is at 0. Axis of symmetry at 0. So if my axis of symmetry is at 0, what's my y-intercept? No. Put 0 in for x, what do you get? 9/4. 2 1/4. Is A positive or negative? Is it up like a cup or down like a frown? Down like a frown. You can figure out your x-intercepts. I don't know if it's said to do that or not. If we set this equal to 0, it's actually really easy to do. How do you undo multiplying by negative 1/36? By negative 36.
Oh, yeah.
And let's see, this becomes what? 9, so we get 81 is x squared. What are your zeros? Plus or minus 9 for your zeros. I'm not sure if it asks you to plot that or not, but that's what you would do. Okay? This one was a little tricky because you're thinking maybe since it was the conic section, I had to go back and use the 4py. They'll do that to you from time to time, make you switch back and forth. Okay? Let's talk hyperbolas because they're fun. Make sure your names are on 7 up. I saw this was kind of cool. It just looks kind of cool. So as you look at a couple of these things, as you take a hyperbola, this is really cool how you can make it work like Etch-a-Sketch or something if you had one. As it goes around a circle, the segments, that's how it's created through.
Whoa.
It's like a spirograph. You ever had one of those?
Yeah. It's like an extra sketch.
What?
What?
I'm bringing one in tomorrow.
The little red TD box with the two dials.
My mom never let me get one of those. So.
What?
I'm bringing one in tomorrow.
What do you think?
I know it's like this.
All right. So anyway, so the difference then with the hyperbola versus the difference that's going to wind up with the hyperbola versus the ellipse is that in the hyperbola, that this a minus b value remains constant. That's, you don't have to write that down, but that's the difference. A hyperbola is going to go one of two directions. It's either going to go left and right, or up and down. What makes a hyperbola a lot different as far as the complexity is concerned to graph it is that there are two extra things that you have to plot through. Remember yesterday we talked about the A, B, and C values? A being the distance from the center to the vertex, B is the center to the co-vertex, and C is the center to the focus. Those three things, those three parts, bless you, still remain the same. They don't change for these two conics. But what's going to happen here is that when you had, remember how yesterday the a squared value was determined by whichever one was bigger? Today, it's whichever number comes first. Whichever one comes first is going to be the a squared. So here's what's going to happen. I'm going to go through all of this with you, just like I did yesterday, in very polite, easy, normal terms. Left and right is if x comes first. Up and down is if y comes first. Okay? And then just go in alphabetical order. A's first, then B.
So the only difference is that there's a minus sign instead of a plus sign?
Yeah. And it's not the A and B that changes, it's the X and Y.
So now A and B don't change that one?
A's always first, B's always second for hyperbola. And remember, again, your calculator will have this for you, all right? Your calculator had that app that says conics, and it's on here. It's on there for you, okay? It shows you that if x squared is first, the picture shows it going left and right. If y squared is first, it's going up and down. It's on there. You don't have to memorize this, but you do have to know what things mean. Today, yes ma'am? If I don't let you use that calculator, I promise you I will give you these formulas. All right, I always do, even on the final, because I know when you take the final and stuff like that, I do have a formula sheet that I give you guys, and this is one of the things that I put on there. Okay? I'm sorry, somebody's stuff was falling. It depends. There might be calculator, non-calculator. It's very common. I think I might change the final up a little bit this year to make it more performance-based as opposed to multiple choice.
No,
Multiple
guess.
guess.
Multiple guess.
We'll see. It's only October. I still got a couple months to write it. Okay. So what happens here is that in order to find the value of C, remember, today and tomorrow for hyperbolas, we're still setting everything at the origin. You don't have to worry about these h's. So technically our h's and k's are both zeros. What's going to happen here is that your center is still in the middle. Your a value is the distance from center to vertex. That's still the value of a. The b value is something that I still call the co-vertex. So a is going to be the distance from center to vertex. B is the distance from the center to the co-vertex. But technically, there is no such thing as a co-vertex in a hyperbola, but we still use it. I forgot what the real name for it's called. I'll look it up and I'll tell you tomorrow. Okay? So it's my homework. So the b value is the distance up and down. Okay? And then what's created in order to figure out these values of c, because remember, where will the focus be in relationship to the vertices here? Will they be inside the vertices or outside the vertices? Are the vertices looking at them or looking away from them? They're looking at them. So your vertices are going to be further out. Because remember, the vertex always looks at its focus. So what we're going to do then is create this little rectangle in there. There is a rectangle that is imaginarily formed between these AB values. Sorry. And what happens then is that you get what are called diagonal asymptotes. And we'll talk about that when we put a real example in. Okay? I'll show you when we do a real example. C is still the distance, center to focus. And then The only thing that changes now is c squared is a squared plus b squared. Yes, ma'am.
Oh, what are the dots? Is that the focus?
The ones outside there, yeah, that's the c value. Sorry, I forgot I didn't label it. Yes, sir.
Okay, so now the equivalent is the fact that you're doing.
Yeah, the one way to remember this is that hyperbolas,
Oh.
you'll never have to worry about memorizing the formulas because they're going to be given to you. And if you notice you have a hyperbola, the subtraction sign is between the two. If it's a subtraction sign between the two, define c, it's a plus sign. Whereas yesterday it was flip-flopped. Yeah.
Wait, so is C from the vertex to the focus or the center?
It's center to focus. It's going to be this longer value here. The c value is always center focus. Thanks. I don't know which one's first. Fight, fight.
What are those like blue diagonal dotted lines?
Horizontal or diagonal asymptotes. I'll explain it when we do a real example. I'll explain how those come about and what they mean here in a second. Same thing. Yeah. What's going to be different here? What's going to be different here is that I'm going to ask that you guys write me the equations in slope-intercept form, the diagonal asymptotes. I honestly don't know. So I usually just call it the asymptote. I think there's a P in there, but I'm not sure.
That's what
Asymptotes? Yeah, remember the whole thing of I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. You can get infinitely closer and closer and closer to something without touching it. That's what an asymptote is. It's the idea of being able to do this. What can't x be? 1, because you can't divide by 0. So if you were to graph this, you'd get what's called a vertical asymptote at 1, because you can't divide by 0. Your graph would approach it, but it will never be it. That's what an asymptote does. Okay? You're going to see asymptotes a lot more as we get into polynomial, not really polynomial, but when we get to exponential logarithmic equations as well as trigonometric stuff. We deal a lot of asymptotes where things are approaching specific values, but they won't quite get there.
Are we gonna have to shade that?
Uh,
I know it's sometimes like when it can't be something you have to shade.
I don't think so. So let me show you an example. The only thing that changes on this side, the A, B's, and C values, they all work the same. The graphs just get shifted. Okay? The graphs are just going to get shifted, and I'm going to get to an example of both a diagonal or an x squared hyperbola today and a vertical hyperbola. I'm going to do one of each, and I'm not going to worry about trying to write equations because we got just enough time to do those two. Yeah.
So, one equation does both like left and right, or we just do one?
It does left and right, yes. Yeah, because they're mirrored. Okay, they're mirrored. So let me give you an example. We'll do this first one together. Graph paper. Who needs graph paper? 4x squared minus 9y squared is 36. We're going to graph this and label everything. We're going to find center, vertex, co-vertex, foci, and equation of the diagonal asymptotes. It sounds like a lot, but once you figure out what your A, B's, and C values are, it's pretty quick. Just like it was yesterday, hopefully, for the most part. Okay. What do you think your first step is going to be? Divide everything by 36. Good. If I divide everything by 36, now which one came first, x squared or y squared? X squared. So is this a left, right, or up and down? Left, right. Again, just draw that off to the side so you know which way to go. Okay? It's a little extra thing to throw in there that does not hurt you whatsoever. And now you start by labeling. if we know that a squared is 9, b squared is 4, c squared is a squared plus b squared, what is the square root of 9?
Plus or minus 3.
Plus or minus 3. What's the square root of 4?
Plus or minus 2.
That gives me my a's and b's. What's 9 plus 4? What's the square root of 13?
Plus or minus the square root of 13.
Yes, sir.
If we don't put the plus or minus two on the test, we get it all right. Good.
Well, here's the thing. When we get to the test stuff, you're not going to be centered at the origin. You're going to be moved all around, and you're going to have to know that you're going to have to add and subtract 3 from a specific set of ordered from a certain center. So your ordered pairs are what I'm going to be looking for.
But if we like do plus or minus 3, if we don't put that plus or minus, is that wrong?
What I'm getting at is, let's say later on your h and k were at -2 and 4, and you had to move this. You have to make sure if it's x, you'd have to add it to the h, so you'd have 1, 4, and then the other one would have been at -5 and 4, something like that. As long as you know what you're doing. But trust me, it's just a helpful piece. Does that make sense? I mean, today it's not so big, but later. Believe it or not, that's really all you need to know to graph. So you start. Our center is at the origin, so we put a dot. We know it's going left and right, so I have to mark off 3 left and right. Those are my vertices. So we can probably start making a list. Center, 0, 0. Vertices, 3, 0, -3, 0. Co-vertice. It's got to go up and down too. And now this is where it gets a little weird. Excuse me. Always. This is the same idea from yesterday when we have A, B's, and C's from ellipses. It does the same thing. Well, I know, so you know. Draw a rectangle. Draw a rectangle going around those 4 points.
Does it have to be a dotted rectangle?
Yes, please, because it's technically not there.
Wait,
Dotted, dash, whatever.
dotted?
Well, in Morse code, there's a difference between a dot and a dash.
Ha ha ha.
Dot, dash, dot, dash.
Make a dot dash box.
Next thing, we're going to put in our diagonal asymptotes. Your diagonal asymptotes are the diagonals of the rectangle. And they will always go through the center. Okay? What's the last thing I got to plot in here? Your foci. Your foci is at plus or minus root 13. Root 13 is bigger than the root 9 and smaller than root 16. Between 3 and 4. So I put a 4 out here, and just put a dot in the middle. Ish. And then I label where I put it. Foci at root 13, 0. Negative root 13, 0. The
How do you know how thin or thick to make the curve?
What do you mean? For the
When you're actually drawing it, is it supposed to go along with the diagonal?
if you're getting the best part, you're leading you right to the best part of the graphing. The best part of the graph is this. You ready? Hug your asymptote, go through the vertex, and hug your asymptote. That's how you graph them. Hug your asymptote, go through the vertex, and hug your asymptote. What? What's so funny?
Yeah, it's so funny.
Lucky. What? So what's wrong with hug your asymptote?
Can you see it slower?
It's slower. Now we have to write the equation of the lines of the asymptotes. What's wrong? It's actually really easy to figure out your slopes here because the center of the hyperbolas today are all at the origin. Rise over run, guys. I went up 2 over 3. What's my slope for one of them? 2 threes, yes. Down 2, right 3, so the other one would be negative 2/3. Okay? Now, what's going to happen is, whenever you have, I'll explain that tomorrow. I'll
So the
define that.
slopes are plus and minus 2.
Yes. But now, what the easy part of today is to write the equation of the lines. Yes, Lori?
For the focus, where did you get that second point?
Which one? The plus or minus 13s?
No, the second one. The one that says root, isn't that say root 0?
It's root 13 and then negative root 13.
Where's the negative sign?
Oh, okay.
Okay, that's what you're doing. Okay, it's not negative sign.
That's just
That's
as
a
that.
negative root b.
That's what
Okay? Now, what's left here is by writing the equation, we have to go back and think about point slope form. Today it's going to be really easy because what's the point that's on the line that's super easy to work with? 0, 0. So if my y-intercept is going to be at 0 and I know my slope, the equations of these lines are going to be y equals 2/3 x and y equals negative 2/3 x. Those are the equations of the asymptotes. Later on, when we're not centered at the origin, we're going to have to use point slope form to write that out. And we'll worry about that when we shift things around. It's just really one extra step. Okay? Yes, hyperbolas have a lot going on. But notice, it's straight off the formula base of knowing what an A stand for, B, and C. And just filling in the blanks. Slopes, you've got that really nice rectangular box that I had you guys put in, so it's very easy to count up and over. I do that differently than some, texts and stuff like that because it kind of forces you to find your slope right away. Okay? Yes, ma'am. We can make it more difficult. Let's try another one that's gone the other direction. Let's go with this one. Y squared over 100 minus x squared over 75. What came first, x squared or y squared? Y. Okay, so it's going to be up and down. Start with labeling. And you hear A, B's, and C's rather quickly.
Do you have to write a straight straight to like a equals plus minus?
It doesn't hurt because what I see happening a lot of times, Haley, is that when you go and do your a squared plus b squared equals c squared, you might accidentally write 10 plus 5 root 3 equals c, and they'd be wrong. You know what I mean? So I try to, hey, I'm all for taking shortcuts. I mean, do that a lot. But I'm also, I try to put down as much information that is just makes everything straightforward. And if I replicate it, plus I'm doing all the same thing for all the other ones. So now we just kind of go for it. We know that it's going to be vertical. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10. Here's my vertex. 5 root 3. Well, the square root of 75 is larger than the square root of 64, but smaller than the square root of 81, so it's between 8 and 9. I've got my 4 points, and you make the box. All right, make it fancy. There's my rectangle. I now make my asymptotes. C value, 5 root 7. Well, 175 is larger than, was it 13 squared is 169? 14 squared is 196, so it's somewhere between 13 and 14. So I'm already up here at 10, 11, 12, 13, 14, so I'll put it here. 11, 12, 13, 14, and put it here. Your favorite time of day, hug your asymptote, go for the vertex, and hug your other asymptote. I enjoy this. Iconics are kind of cool.
There's too many dotted lines.
We'll make them dash lines then. Then make them dotted. Yes, ma'am.
No, this isn't great, but like, when will we ever actually use this?
I'll show you. Because these are all, it's a lot of this stuff is physics related.
Like, not just like this, but like the ellipsis and the...
It's a lot of it is the physics related for like if you're using any of those things. But more often than not, the conic stuff just uses the idea of that upper level algebra of leaving the square, solving larger equations and things like that in plotting. That's kind of problem solving stuff that they do in algebra too.
So basically...
No one's done a job.
Not be a physics major.
Artie, what do you got?
The asymptotes like always the
Yes.
corner of the data.
Yes. Yep. They're always the vertices. They're always the diagonals of the rectangle. And that's why I draw the rectangle, because then I can get that through there. And then I can obviously just count. I know I went up 10 and I went over 5 root 3. Lori?
That's what I was Wait, so this is really unsure. Why is it called conics?
Oh, conics because of the curvature. They're cutouts of curves.
Are you lying?
No. I'm positive. This is 85%. Conics, they're called conics because they're cut out of curves. Because if you...
I thought Mr. Seb showed us something last year where like you draw the ball.
Yes, and these are all that's where all these are come from. You can cut sections off of a cone to get other parts. That's where they're cutouts of cones. That's where they get it. Yeah. So our slopes, they're easy because they're going to be plus or minus going both directions. So it was up 10 over 5 root 3. So that means this is going to be 2 over the square root of 3. Oh no, I have to remember how to rationalize. Oh no, what is 2 over root 3?
Don't know.
Very good, it's 2 root 3 over 3. So our slopes are both going to be plus or minus 2 root 3 over 3, which gives us both equations then. Your asymptotes equations at y equals plus or minus 2 root 3 over 3 times x. Not the nicest slope in the world I have to walk, but that's what it is.
How would you walk that?
Like this. I mean, you can walk sideways if you want.
That's where I was jumping.
Not even, I'm trying to, I'm mocking you. You can moonwalk. No?
I can't see.
Oh, you want me to move? Sorry. So what I have for you guys tonight are, I think I have like 5 of them.
There's 6 of them.
6 of them, sorry. Now, guys, I know that there seems to be there's a lot, but I didn't label everything on this book because I wanted to make sure you guys understood where things were going. Make sure you label make a list of things of where you're at. Put them through that way. The idea here is that I want you guys to get comfortable with writing the equations of the asymptotes. Those are questions that I ask you guys a lot. With the equations of the asymptotes, there are so many things you can pull out of there. If you know the slope of the asymptote, you can figure out what your A's and B's are by working backwards. So there's a lot of stuff that you can do out of these things, okay? Just wanted to get you guys familiarized with the way these things look. I believe I already put the homework on, I know I put it on the calendar, I don't think I put it on the website page though, did I? No.
It's on the calendar.
I know it's on the calendar.
It's like, it's 36, 34 even.
It's 3242, right?
42.
Yeah. So it's on the 10-5.
Okay.
I'm double checking. I want to say it's 608. 619. I'll put it all here. So this is on. Yeah, today you're going to be okay with that because your other point, because you're always going through the origin. But as soon as we start shifting things around, once we start putting things in space, where you have if your vertex is at, let's see, 2, 3, it's at 3, 2, and you're going up.
Now she needs to turn that in. It's gotta be that paper.
You still got to find the slope from here to here, which is easy, just your rise over run. It's still going to be your A, B, or whatever, how it sets up. But then you have to pick one of the points with that. Yeah. Okay. Give those a shot, see how we do. I don't think you guys have too much of a hassle. If you did okay with ellipses, you can do okay with this. Yes, Jory?